Hello guys, myself Meet Nagadia, and today we'll be doing a deep learning project. We'll be using deep learning on Mnist Dataset for digit recognition. So basically our project is to recognize digit using deep learning model. So Mnist a dataset where we have numbers from 0 to 9 and we have to classify whether what is that number is. So let's get it right. So first we'll need TensorFlow for it. So let's first import it. So if you have not downloaded or TensorFlow on your computer, then you need to download it. You have to create a new environment and download the TensorFlow so that it doesn't conflict with other libraries. I'm using Anaconda here. You can also use Colab where you can just directly import TensorFlow. So I'll just first import TensorFlow to see if I have installed or not. So I have successfully imported it, and now I will check the version. So tf dot underscore underscore version underscore underscore. So by this we can know the version of TensorFlow, and we can also get the GPU, means if GPU is available or not. So for that what we can do is we can simply write tf dot test dot is underscore build underscore with underscore GPU underscore support. So it will return a boolean value either true or false depending upon the CUDA available or not. So here it's saying properly that I have properly installed the GPU and the CUDA version for it. So let's move on. Now what we'll do is we'll import all the necessary libraries. So let me just import the necessary. So I'm writing a comment here that we are importing library. So first of all, what we can do is we'll import NumPy as NP. We'll import pandas as PD. Now we'll import matplotlib for visualization dot pyplot as plt. So these are the basic libraries that we need, and now we'll import TensorFlow. So first of all, I'll say import TensorFlow as TF. Then we'll import Keras. So our dataset, that is Mnist dataset, is available in keras.dataset. So we'll import that also. So for that we'll write import TensorFlow dot keras dot datasets import Mnist. Now we can import our sequential from keras, and we'll then import our layers also. So for that I'll require TensorFlow dot keras dot no not dot okay, so here it will be from and not, and here also from. Will import sequential. Now what we'll do is we'll import the layer. So from TensorFlow dot keras dot layers we'll import dense. And finally we now need the matrix for evaluation purpose. So for that we'll import sklearn matrix. So for that we need from sklearn import matrix. Okay, so that's it, we need this. So here I like to note one thing, that instead of keras we can use TensorFlow dot keras, because TensorFlow keras is now merged into TensorFlow, so we can directly call any packages of the keras from TensorFlow dot keras and then the rest. So here we have successfully loaded all the things that we need, all the libraries that we need. Now we'll load our dataset. Loading our dataset. So here we'll create a tuple. First will be X train, comma, then it will be Y train, and here will be X test, then will be Y test. It would be equal to Mnist, where we have our data, dot load underscore data. So it will download the data, as I have already downloaded the data, so it will just run. But if you are trying for the first time, it will download the data. So let's check what is the size of our data. So let's take the training. So xtrain dot shape. So it will tell us. So we have around 60,000 images. So this is the dimension. Now let's how many we have in our test. So x test dot shape. So we have around 10,000 images. Okay, so now we have checked. So we will plot the image so we can know how our data set look like. So we'll say displaying the digit. So for that I will use matplotlib. So matplot.imshow, and here I will use train data. So train, and here I will just print 1, that is the 1th index of the dataset. So 1 comma the dimensions, and then I'll write cmap. Cmap is equals to gray, gray, and plt dot show. So we'll display the first index of the image of the dataset. So this is the image, and now let's print the label for it. So we'll just need Y train because we have used X train. So Y train, and we'll put index as 1. So see, so here we have our image and here is our label. So we have successfully done it. So let's plot one more. So we'll say plt dot imshow, and here I will now use x test, and I will also do the same thing. I will say, let's say 1 only, and here we'll say cmap is equals to gray, and now plt dot show. So we have 2 here, so let's print also its label. So we have y test and 1. So as you can see, we have our label and our image. So basically now our image has been plotted and we also get our label. So now what we'll do is we'll check what are the classes, how many labels are present. So for that, what I'll do is I will convert this y test into a data frame, and then we'll check the value, we'll check the labels using value underscore count. So I'll write checking the labels. This is completely option, we don't need to do this, but just for seeing how many labels we have. So what I'll do is I'll write y underscore trains is equals to pd dot data frame, and then we'll write our data, that is x. So now we'll write y underscore trains is equals to, not equals to, I mean value underscore counts. So we have around 10 labels from 0 to 9, and we have this much values for each label. So we have this much images for each label. So if you try to print any one of the label, it will not directly show us the image, it will give us the array. So let's say x train, and then we'll say 5. See, we got this because it will not directly show us the image, it will be an array. So now what we'll do is we'll uh, reshape the training data as well as test data so that we can easily represent train and testing samples that will be suitable for TensorFlow backend. So for that, what we'll do is we'll write x underscore train, which would be equal to x train dot reshape, and here we'll again give x train and shape of 0 index, comma, we'll give 784 as dot s type, and it would be float 32. We'll do same for x test also. So we'll write x test x train dot reshape the same x test, or either here it is x test dot shape 0 784 dot s type float 32. And now we'll divide it by 225. So x underscore train would be equal to x underscore train divided by 255. Same goes for x test. This is equals to x underscore test. It would be divided by 255. So we have done that successfully. Now it's time for y test and y train. So let's first take y train. Here we'll convert it to categorical. So for that we'll require keras dot utils dot to underscore categorical, and we'll put y train comma 10. Same goes for y test. Y test is equals to keras dot utils dot to underscore categorical, and y test comma 10. Oh, so we haven't. Okay, so we haven't imported Keras, so we'll just write here import TensorFlow import Keras. Here it will be from. So yeah, it is successfully done. So now it's time to create our model. So for that, what we'll do is we'll first initialize it. So for that, we'll just write creating our model. So now what we'll do is we'll write model is equals to sequential, and then we'll add in layers to it. So we'll write model dot add, and here we'll add dense layer. So dense, and we'll give 784, comma, we'll give activation function as relu. We'll copy it once again and just paste it. And now what we'll do is for the final layer, we just have 10 labels, and we'll use softmax function here. Yep, that's it. So here our model is being created. Now what we'll do is we'll give the optimizer the value evaluation metrics. So for that we'll write model dot compile, and here we'll give loss is equals to categorical underscore cross entropy, and we'll write optimizer as Adam. Optimizer is equals to Adam, and now we'll give our matrix is equals to accuracy. Yep. So now it's time to fit our model, that is give the training data. So for that I'll create a variable history which will store the model.fit, and we'll give here x underscore train comma y underscore train, and we'll provide epochs. So here I will be giving 50 epochs. Epochs is equals to 50 comma batch size. So batch size will be BAT batch underscore size is equals to 256 comma verbose is equals to 0, no 1. So our epoch is being started, and we can see that our loss is 0.231 and accuracy is around 0.9311. So our model is being trained on the training data. So let's wait for a few seconds so that it completely gets trained, and see here on I'll getting accuracy completely as 1, that is 100%, and our model is being trained and we are getting accuracy of 1. So we can do one thing, we'll try on loss comma accuracy is equals to model dot evaluate, and we'll write x underscore test comma y underscore test, and we'll give verbose as 0. Now we'll print the accuracy as well as loss. So for that I will write our losses, comma, loss and our accuracy. So ACC accuracy, comma, accuracy. So our accuracy on the training data is this and loss is this. So it is pretty much good, we can say. Now let's plot the loss versus um, train. So for that I'll write plt dot, let's say first give us the title and it was loss. So and now what we'll do is we'll plot, so plt dot plot. So here we'll use history dot history, and here we'll give the parameter index as loss and we'll give label as train. Okay, plt dot show, and also we can write as plt dot legend. So it is giving the loss. Yep, we'll do the same thing, so we'll just copy paste it. We don't waste too much more time. A double C URACY accuracy, and here it will be just ACC. It's not ACC, we have to write it completely, I'm sorry. Yep, so accuracy. Now what we'll do is we'll predict, we'll create and we'll do one thing. We'll now do y, not y underscore predict. We'll try to use our own image and then we'll try to classify it. We'll not literally use our own image, we'll just check if our model is completely getting what the image is. So we'll write model dot predict and we'll do one thing. We'll test the training data for ourselves and then we'll try to get the matrix, that is confusion matrix, from it, as well as we will get the classification report on each of the label. So for that what we'll do is we'll, rather than taking the x train here, we'll just take x underscore test. So we'll predict all the values from the x test. We have done that. So now what we'll do is we'll say y underscore predict and then we'll say 1. So here we'll get an array, so this represents the label. So for that we need to get the label, so we need to use numpy for that. So we'll write np dot argmax and then we'll say y underscore predict and 1. So here is our label. So let us check by plotting that. So we'll say plt dot, we'll just use imshow as we did earlier. So we'll say here x test and here will be the index which we have used as 1. I guess we have already done this, right? It was 2. And here we'll write cmap, let's check it. It's gray. And plt dot show. We can skip dot show pld, that's no, yeah, we got 2. So our model predicted very accurately. So now what we can do is we can create a confusion matrix based on the training data, based on the test data that we have predicted. So for that, we'll say creating not creating confusion matrix. We'll say y underscore pred will take an empty list, so we'll append all the values in it. So for that, so now what we'll do is we'll write for index in y underscore pred. Here we'll append everything. So here actually it will be predict and not pred, because here we have used the x under y underscore predict. So y underscore predict. Now we want to append it in y underscore pred. So now we'll use y underscore pred dot append, and here we'll give the index, but it will not be index. We have to convert it into label. So for that we'll use numpy. So we'll write np dot arg max, and if we want we can print y underscore pred. So let's do it. So here we get the label, as you can see, so we don't need. So what we'll do is we can leave that as of now. Now what we'll do is we have created we have got our label, so we can now create a confusion matrix. So let's say we have cm dot, that was confusion matrix, is equals to matrix from sklearn. Here we can create a confusion matrix using confusion underscore matrix, and here we'll pass our y test data, comma our prediction, which is y underscore pred. We have converted it, so we'll use spread and not predict. And we'll also like to print it, so we'll just say it is good practice to write print rather than just the variable name. So this is our confusion matrix. So our model has correctly identified 0 975 times, and these are all the wrong predictions that our model has made. So now we can do one more thing, is we can create a classification report. So for that it is very easy. So what we can do is we can write creating classification report using matrix. So what we'll write, we'll say we consider a variable cr classification report. We'll write matrix dot classification underscore report, and we'll pass our test data, which is y test, and our prediction, which is again y underscore pred, not predict. And then we'll write print cr, which will print our classification report. So this is our classification report. We can see 0 is almost every label is classified above 98%. So our model did exceptionally well. um, So that's it, guys. This was deep learning on, okay, I haven't wrote the digit recognition using deep learning. So that's it, guys. This was all about digit recognition using deep learning. Hope you find insightful. The link to this notebook, Kaggle notebook, and GitHub will be down in the description. Thank you for watching. Have a great day. Happy learning.